Everyone, welcome to this video. Today we are going to understand the construction of an induction motor using actual parts. Myself Jayesh Naik, and through this presentation I'll walk you through each component and explain its purpose and function in detail. Now let's start by understanding what an induction motor is. It is an AC electric motor that works on the principle of electromagnetic induction. This means that current in the rotor is induced but not supplied directly. In simple terms, when AC supply is given to the stator winding, it creates a rotating magnetic field. This magnetic field induces a current in the rotor by Faraday's law, which in turn creates its own magnetic field. The interaction between this magnetic field produces torque, causing the rotor to turn. Induction motors are considered the workhorses of industry. They are used in motors are considered the workhorses of industry. They are used in factories, power plants, water treatment facilities, and even in domestic appliances. A question may arise in your mind that why are they so popular? They are popular because they are rugged, cost-effective, and highly reliable. Their simple construction makes them durable under tough conditions, and they can run for hours with minimum maintenance. So there are mainly two types of induction motors based on the rotor design. First is the squirrel cage induction motor, which is most commonly used, simple design with rotor bars shorted by end rings. And second is the slip ring or a wound rotor motor, which includes winding connected to external resistors via slip rings, allowing control over starting torques and speed. Now I'll explain parts of an induction motor. First is stator. So the stationary part of the induction motor is called a stator. It consists of laminated iron core stacked together, forming slots where the three-phase windings are placed. When three-phase AC current flows through these windings, it produces a rotating magnetic field that induces current in the rotor. Next is the rotor. The rotating part in the squirrel cage motor is the rotor. The rotor consists of bars connected off at both ends of rings, forming a cage-like structure. These bars are placed in the laminated iron core of the rotor. The current is induced in these bars by the stator's magnetic field, and that's what produces torque. The shaft is a strong steel rod mounted centrally inside the rotor. It transmits the mechanical power generated by the rotor to the load, like a fan or pump. It's designed to withstand high torque and continuous rotation. Bearings are placed at each end of the shaft. Their job is to reduce friction and support smooth, noise-free rotation. Bearings are crucial to ensure the motors runs efficiently and last longer. These are the end shields, also called as end covers. They hold the bearing in position and protects the internal moving parts from dust, damage, or foreign particles. The frame or the body of the motor encloses and supports all components. It provides structural strength and also acts as a heat dissipator. Most frames are made up of cast iron or aluminum depending on the applications. Cooling is essential for the continuous motor operation. This fan fixed at the back of the rotor shaft circulates air and prevents overheating. The fan cover ensures safety and prevent damages to the blades. This is the terminal box, usually mounted on the rotor motor's frame. It's where we connect the incoming power supply wires to the stator winding terminals. Power insulation and connections are critical here. Now let's understand how these parts come together. The rotor is inserted inside the stator and the shaft is supported by the bearings at the both ends. These bearings sit in the end shields, which are then fastened to the frame. The cooling fan is mounted on the shaft and the terminal box is wired for power connection. Once the stator is energized, then the rotor begins to rotate due to the principle of induction, and The shaft starts delivering mechanical output. Induction motors are 100% efficient. They have some losses. So here are some common losses. First is stator copper losses, which is due to resistance in the stator winding. Second is rotor copper losses caused by induced current in the rotor bars. Third is iron or core losses, including eddy current and hysteresis losses. Fourth is friction and windage losses due to the rotating parts and air resistance. Fifth is stray load losses, which are minor and caused by leakage flux. Let's quickly compare the two motor types. Slip ring motor have wound rotors with slip rings and external resistances. They are suitable for high torque applications like cranes and hoist. Like heavy works, squirrel cage motors have fixed rotor bars and are compact, durable, and maintenance free. They are used in fans, compressors, and general purpose machineries. While slip rings motor offer better speed control, squirrel cage motors are more economical and widely used. Now, induction motors offers multiple advantages. They are simple and robust construction. It's cost effective and have low maintenance. Self-starting, which eliminates the need for starters in low ratings. Reliable performance over long periods. Wide range of applications, making them the most commonly used electric motors. Applications of induction motors in industries for powering machines, pumps, compressor, and tools. Induction motors are used in commercial buildings for elevators, air conditioning, and ventilation. In homes for refrigerator, washing machines, fans, and water pumps. Their versatility is one of the main reasons for their global popularity. In conclusion, induction motors are essential to modern life, whether it's industrial, commercial, or domestic use. Their simple, brushless, and reliable design makes them an engineer's first choice. From fans in our homes to heavy machineries in factories, they